So when it comes to polynomials, it turns out that multiplying polynomials is easier than adding and subtracting polynomials. Basically, let's go over a quick review of what a polynomial is. It's a number, one number, with many parts, and the parts are called terms. So it's a number with many terms. So each term, remember, has three components. There's the sign, it's either positive or negative. There's the numeral. That's the part we think of as numbers historically. And then there's the variable configuration. So the sign, the numeral, and the variables. If I were to write the number -8, that is a polynomial because it has a sign, it has a numeral, and the variable configuration in this case would be x to the 0, which just equals 1, so we don't tend to write it. So -8 is a polynomial. In fact, it's a monomial because it has only one part. Another example would be 2x squared. This is also a monomial because it has only one part. It has a sign, it has a plus sign that we only write down if we need to. It has a numeral 2, and it has a variable configuration. And so this is also a monomial, polynomial, or a monomial number. And one more example, x squared plus 3y is a polynomial. It is two parts, so it's called a binomial, and each term has all three components. The x squared has a sign that we don't write down unless we need it. There's a numeral, which is a 1, also we don't write down unless we need it, and then a variable configuration. The second part has a sign, it's positive, it has a numeral 3, and it has a variable configuration, and this is called a binomial because it has two parts. This is a monomial. And this is also a monomial, which just means it has one part. So polynomial multiplication just means you have to multiply all the parts to all the parts. So all the parts of one polynomial to all the parts of the other, or the second polynomial. And remember, this big fatty P stands for paragraph in English, but it's the way we write polynomial without having to write the long word out every time. Let's do a bunch of examples because that's where the real learning is in this lesson. Now, I use a method called rainbow or distribution. The book, your textbook, shows you at least two other methods. In the long run, the method I'm about to show you is the one that will work better through all the maths of your future. And so it's the one I teach. It's the one I recommend. I don't really mind if you go to the book and learn another method, as long as when you use it, it's obvious to me what you're doing so that I can grade you appropriately and assess your development and your learning appropriately. So we're going to start by multiplying a monomial times a binomial. Okay, so clearly we have a monomial and we have a binomial. And when we multiply, we're going to multiply each part in turn. First, we're going to decide on the sign by multiplying the signs. Then we're going to multiply the numeral part, and then we're going to multiply the variable part. And so in this case, and I call it rainbow because I do that, that's the only reason, the signs first. So this is a +2 and this is a +3, so a positive and a positive is a positive, and I don't need to write it, but I'm going to just to make the point. And then the numeral part, 2 times 3 is 6, and then the variable part, x times x squared is x cubed. So I've multiplied the first part of the first number, which happens to only have one part, to the first part of the second number. Now I'm going to multiply the first part of the first number to the second part of the second number. So a positive and a positive is a positive, 2 times 4 is 8, and then multiply the x's. Well, this is x to the 0 power, which means x to the 1 times x to the 0 is x to the 1 plus 0, so I just have 1x. Often when you're multiplying the variable, it's easier just to count them up. In this first case, I had 1 and 2, so 2 plus 1 is 3. Just count them up using your properties. I'm done. That's the final answer. We're good to go with that one. Let's multiply a monomial times a trinomial. Let's multiply negative 3x squared times x squared minus 2x plus 7. Again, I'm going to multiply the one part of the first number to each part of the second number. So the first one, a negative and a positive is a negative. 3 times 1 is 3. And then let's count up our x's. I have 2 here and 2 here, so I have 4 altogether. Then I'm going to multiply the first part to the second part. A negative and a negative is a positive. 3 times 2 is 6. And now count up my variables. I have 2, 3. And then, last but not least, a negative and a positive is a negative. 3 times 7 is 21. I have 2 x's and I have 0 x's, so 2 plus 0 is x squared. Okay, that's a monomial into a polynomial. And as you can imagine, this could go on forever. If my second number had 17 parts, I would just keep producing rainbows 17 times till I got to the last one. And that would be a fully distributed monomial into whatever size polynomial you're multiplying into. Let's do an example this time. We're going to multiply a binomial times another binomial, negative x plus 3x squared. Now, it's not written in descending order. It's okay. Eventually, if I have to group terms, I'll have to put it in descending order, but let's just see where we are beginning now. I'm going to multiply the first part of the first number in turn to each part of the second number. So the first part to the first part gives me a negative and a positive is a negative. 2 times 1 is 2. 1x and 1 more x is x squared. I have 2 x's. Now I'm going to multiply the first part to the second part. A positive and a positive is a positive. 2 times 3 is 6. 1x and 2 more x's is 3 x's. So now I've actually multiplied 2x to all the parts of the second number, so I'm really done with that one. I don't have to do anything else with that one. Now I'm going to multiply the second part, and I like to put my rainbow on the bottom this time just because it's neater. It doesn't get all jumbled up in my top rainbow while I'm learning, but you don't have to. It's up to you. A negative and a negative, because I'm multiplying the second part of the first number to the first part of the second number. A negative and a negative is a positive. 2 times 1 is 2. 0 x's and 1x is 1x. And now the second part to the second part. A negative and a positive is a negative. 2 times 3 is 6. 0 x's and 2 x's, 2 x's. Now I look to see if I have any like terms to combine, and I do. I have x squareds here and I have x squareds here, so they have to be combined. But remember, I mentioned a moment ago that I want to write it in descending order when I combine those terms. So I'm going to start with the biggest power on the variables, and in this case it's an x cubed. So I'm going to start with x cubes. I only have one, and that's a positive 6x cubed, so I'm going to write that. And then I have 2x squareds. One is negative, the other is negative. Negative 2 minus 6 is a minus 8x squareds. Notice I'm not adding my x's, I'm combining them. I'm taking all the members of this house and all the members of this house and putting them together. If you have 6 people in the x squared house and you put 2 more people into the x squared house, you get 8 people. And because they're both negative, you get minus 8. I almost made my own mistake there with multiplication. So, or I like to think of it as I have negative 2 green marbles, take away 6 green marbles, negative 8 green marbles. So I'm done with my squareds, and now plus 2x. Okay, let's do a tough one. Let's multiply a binomial, 3x minus 4, times a trinomial, 2x cubed minus 6x squared plus 8. Let's see where this takes us. We have a method, so we don't have to panic over the big numbers. We're just going to take it step by step. We're going to take the first number, and in turn multiply it to each number. We're going to take the first term of the first number and in turn multiply it to each term of the second number. So 3x times 2x cubed, positive and a positive is a positive. 3 times 2 is 6. X, there's 1x. 3 more x's is x to the 4th. Now to the second term, negative. 6 times 3 is 18. 1x and 2 more x's is 3 x's. Now to the third term, positive and a positive is a positive. 8 times 3, 24. 1x, 0 x's, I have just 1x. Now, I have finished with that first term. It's been multiplied to all the parts of the second number. Now, let's multiply the second part of the first number to each part of the second number. A negative and a positive is a negative. 4 times 2 is 8. 0 x's and 3 x's just leaves 3 x's. A negative and a negative is a positive. 4 times 6 is 24. 0 x's and 2 x's is just 2 x's. And then a negative and a positive is a negative. 4 times 8 is 32. No x's anywhere, so no x's. Now I have to combine my like terms. My biggest power is a 4. And I only have one of them, so I'm just going to write it down, 6x to the 4th. I have 1, 3. Oh, I have another 3. So I have negative 18 minus 8. Remember, you combine like terms by just adding or subtracting or combining the numeral. Negative 18 minus 8, negative 26, green marbles. Now, only 1x squared. Done with that one. Only 1x. Done with that one. And negative 32. And so I have written this polynomial in descending order. So I can identify that it is a 4th degree. I know we covered this on our previous video, but there's never too many times to make sure we understand how to identify polynomials. It has 1, 2, 3, 4, 5 terms. It has a constant of negative 32. It has a leading coefficient. That's the coefficient in front when it's written in descending order. A leading coefficient is positive 6, and all the other coefficients, or all the coefficients including the leading coefficient, are 6, negative 26, 24, 24, and negative 32. Okay, I think we have time, just enough time. Let's multiply a trinomial times a trinomial. So, negative 2x cubed plus 3x minus 6, that's a trinomial, and we want to multiply it by a trinomial. 3x squared plus 2x minus 4. All right, we have a method. We're just going to use it. We're going to multiply the first term to the first term. Negative and a positive is a negative. 2 times 3 is 6. 3 x's and 2 more x's would be 5 x's. Next term, Negative and a positive is a negative. 2 times 2 is 4. 3x's plus 1x is 4x's. Negative and a negative is a positive. 2 times 4 is 8. 3x's, no more x's, 3x's. I'm going to change color this time rather than loop below. Second term, because I've finished the first term, right? I've multiplied the first term to all 3 terms of the second number. So now, a positive and a positive is a positive. 3 times 3 is 9. 1x plus 2x's is 3x's. A negative, or a positive and a positive, excuse me, a positive and a positive is a positive. 3 times 2 is 6. 1x plus 1x is 2x's. A positive and a negative is a negative. 3 times 4 is 12. 1x and no x's is just 1x. And now another color change. I've finished multiplying the second term to all 3 parts, all 3 terms of the second number. And now I'm going to multiply the third term to all 3. Negatives and a positive is a positive. 6 times 3 is 18. 0 x's and 2 x's means that there are a total of 2 x's. A negative and a positive is a negative. 6 times 2 is 12. No x's and 1x, total of 1x. And I don't really need to write that 1 on the power, do I? Last but not least, a negative and a negative is a positive. 6 times 4 is 24. And no x's and no x's means there are no x's anywhere. Now let's combine them. Well, highest power, first thing we want to do is scan and see. Well, the highest power is a 5. So I want to write negative 6x, that's to the 5th, right? So that's these. And a handy way to do that sometimes when they get long like this is to give yourself a shape. So box in the x to the 5ths in a square, and then the next one, maybe use a circle. So I have, here's an x to the 4th, and there are no more x to the 4ths, so minus 4x to the 4th. And then the next one would be looking for thirds. Let's choose a triangle. Oh, that's kind of hard to do there, isn't it? There we go. 8x cubed. Oh, look, there's a 9x cubed. Is there another x cubed? Nope, there's 2 of them. So I'm going to combine them. 8 plus 9 is 17 x cubes. Okay, let's look at the 2's. This time I think I'll just underline. So x squared. And I have another x squared. That's all I've got. So let's add them or combine them. 18 plus 6 is 24 x squareds. Next, I'm looking at running out of colors here. Let's do a parenthesis. So a single x and a single x. Combine them. Negative 12 and negative 12 is negative 24 single x's, and then the last thing I have to deal with is my plus 24. Luckily at Algebra 1 you won't have to do a lot of problems that are like this, but it's good to know that you have the tools to do it if they come up. Remember, this first step going from here to here is called multiplication, which when we're talking about polynomials, we're talking about distribution. And then to go from the second step from here to here, we're talking about addition and subtraction, which when we're talking about polynomials, we call combine like terms. So when I'm working with PEMDAS, right? Now we have a way with polynomials. We still can't divide polynomials, but we can multiply and add and subtract polynomials. This is distribution without the D. I guess I could write that better. Let's do this. This would be the distribution. By the way, when we divide, it's called factoring. Might as well give you a name for it now. And then both of these together are called combine like terms.